Welcome! Today in this video we finish Unit 9, Solving Inequalities. We look at Day 3, Inequalities involving quadratic functions. Here's a quick example of the kind of thing that we'll look at. We have a quadratic, x squared minus 8x plus 12, and we want to know when is that greater than 0. This is section 4.5 from the book, and this section has one objective, so that's what we will study. Solving inequalities of quadratic functions based on the graph. Let's begin by looking at the graph of a quadratic and answering some questions about inequalities. So, consider the graph of f of x equals x squared minus 4x minus 12. That's what's graphed to the right. Use the graph to solve. F of x is greater than or equal to 0. So the f of x refers to the y values. Where are the y values greater than 0? So it looks like if I extend the graph, maybe it becomes a little more obvious. The y values are greater than 0 in the area that I've just shaded red. And so the question is really, what are the x's that make f of x greater than or equal to 0? So I look below those red areas on the x-axis, and I see that those x values, those are the x values that answer my question. Well, which x values are those exactly? You notice that there is an intercept at negative 2, 0, the x value of negative 2. Do I want to include negative 2? When I put in negative 2, I actually get an answer of 0, but that's okay because I have a weak inequality. I also want to know where f of x equals 0. So f of x is greater than or equal to 0 if x is negative 2 or less. So I could write that negative infinity up to negative 2 inclusive. Or also looking at the right part of the graph, if x is 6 or greater. So 6 or greater. And I take the union of those two intervals. So that's the solution to this problem. Those are the x values that make f of x greater than or equal to 0. Let's look at the next question. Use the graph to solve f of x is less than or equal to 0. Shading the graph again, what are the y values I'm considering now? That's the part of the parabola that lies below the x-axis. So what are the x's that make those y's less than 0? And now I look in between the two x values, in between the two intercepts. So I start at negative 2, x equals negative 2, and I end at x equals 6. And again, it's a weak inequality, so I can include the negative 2 and the positive 6. Negative 2, 6, make it a closed interval, and there's our solution. Here's another question that involves two functions, f and g. In this picture, f is the parabola, g is the straight line. Use the graphs to solve f of x less than g of x. So f is the parabola, g is the line. Where is the parabola less than the line? And I really mean the y values. So I'm shading it now. These are the points on the parabola where the y value is less than the y value of g. So these are the points where f of x is less than g of x. And what are those corresponding x values? So it starts here at x equals negative 2, and it ends at the next point of intersection where x equals 1. Now, I have a strict inequality this time, so I want my x to be strictly greater than negative 2 and strictly less than 1. So how about negative 2 up to 1? And I make that an open interval. I don't include the endpoints. Next problem, use the graph to solve g of x less than or equal to f of x. So now g of x, that's the line. Where is the line less than or equal to the parabola? So I can see it on the right here when I go out to the right of that point of intersection, and also to the left. If I continue the line on, and if I continue the parabola up, all those parts of the line, that's where the line is less than the parabola, where g of x is less than f of x. So the x values I want are less than negative 2. Oh, but this is a weak inequality, so I actually can include the negative 2 also. So negative 2 onto the left, and from here, my x value of 1 onto the right. So I get everything from negative infinity up to negative 2, including the negative 2. together with 1 up to the right. Usually, we want to solve an inequality when I don't have the graph. So let's look at the general strategy for solving this kind of a problem. Let q of x be a quadratic function, where a, that's the coefficient on the x squared, we'll assume that a is greater than 0. Now, what do I know about q of x? Even though I don't know exactly what it looks like, I do know that it's a parabola that opens upward. So maybe it intersects the x-axis at a couple points. Here's how we would solve q of x is greater than 0. First, I find the x values, x1 and x2, let me label those, x1, x2, where q of x equals 0. That's the point of intersection, where q of x equals 0. Then, the solution to the inequality is negative infinity up to x1 union x2 up to positive infinity. Those are the x values where my quadratic is greater than 0, where the parabola lies above the x-axis. Now, to solve q of x is less than 0, we do the same thing, basically. Find the x values, x1 and x2, where q of x equals 0. But now, the solution is the interval between x1 and x2. Those are the x values that make the parabola lie below the x-axis. We can adjust these answers accordingly if I have weak inequalities, like greater than or equal, less than or equal. In the first case, the solution would be negative infinity up to x1 with a bracket, union bracket x2 up to infinity. And in the second case, I'd have the closed interval from x1 to x2. All right, let's do a few actual examples. Example 1. Solve x squared minus 8x plus 12 is greater than 0. This is perfectly in the form that I want. It's a quadratic with positive coefficient, so this is in standard form, and right now it's greater than 0. So step 1 is solve the equality. So let's solve x squared minus 8x plus 12 equals 0. Now, that quadratic does factor. I think it's x minus 6, x minus 2 equals 0. So it looks like my solutions are x equals 6 or x equals 2. Now, just very roughly, if I were to graph this parabola, I have the x-axis. There's a parabola that opens upward, and I know that it crosses that x-axis at 2 and 6. So if I'm looking for solutions where the parabola is greater than 0, I'm looking for the two arms on either side. So my x values are going to be the ends. So everything less than 2 and everything greater than 6. So the solution to the inequality problem is negative infinity to 2, not including the 2, union 6 to infinity. And again, I don't include the 2 and I don't include the 6 because it is a strict inequality. Example 2. Solve x squared minus 1 is less than 3x plus 9. First, I need to move everything to the left of the inequality. Let's put this quadratic into standard form. So how about if I subtract 3x from both sides? I get x squared minus 3x minus 1 is less than 9. Then I subtract 9 from both sides. X squared minus 3x minus 10 is less than 0. And now I try to factor the left side. I want to solve the equality. So if I say x squared minus 3x minus 10 equals 0, where does that happen? Let's see, can I factor? I think I can. 2 and 5, how about minus 5 plus 2? So x minus 5, x plus 2. So x equals 5, or x equals negative 2. So if I'm thinking about the parabola, it intersects the x-axis at negative 2 and positive 5, and looks something like that. It's an upward opening parabola. So if I want to solve where is this thing less than 0, it's going to be these x values in between negative 2 and 5. So the solution to the inequality problem becomes the interval from -2 to 5, just like that. Example 3. Solve this thing. All right, well, we have to do a bunch of simplification first before I can find the points of intersection. So how about if I distribute the -3 on the left, and then I'll pull all this stuff from the right. I'll pull all that over to the left. All right, so first distribute the -3. -3x squared plus 12x is less than or equal to -2x minus 5. Let's add 2x to both sides. -3x squared plus 14x. Oh, and then I'll also just add 5 to both sides at the same time. So plus 5, and that's less than or equal to 0. So it's almost in the form that I want. The bad thing is there's that negative sign out in front of the x squared. Well, I can fix that by multiplying both sides by -1. What will happen on the left, I need to be sure to multiply everything through by -1. On the right, of course, 0 times -1 is still 0, but this inequality will switch. So I end up with 3x squared minus 14x minus 5 is greater than or equal to 0. Now it's in the form that I like. Now I can solve for equality. Where does this thing equal 0? At this point, you might need to dig back into your memory and think about some different factoring techniques. Since the coefficient in front of the x squared is greater than 1, we need to multiply the 3 and then -5 together. That's -15. So find two numbers that multiply to make -15, but they also have to add to make a -14. So with a little bit of thought, maybe something like a -15 and a +1 work. And then you can split this up. 3x squared minus 15x plus x minus 5 equals 0. And I can factor by grouping. So 3x times x minus 5 plus, well, that's just 1 times x minus 5 equals 0. And so we have 3x plus 1 times x minus 5 equals 0. So individually, what x values will make each factor equal 0? In the first case, -1/3 works. So x equals -1/3. Or in the second case, 5 works. X equals 5. All right, finally, we're at the point where I know the 2 points of intersection. This is a parabola that opens upward. The 2 points of intersection are -1/3 and +5, and the parabola kind of comes down and then up. So if I want to solve the inequality where the parabola is greater than or equal to 0, I'm looking at the two tail ends. Since my inequality is a weak inequality, I can include the endpoints. So the solution becomes -∞ up through -1/3 inclusive, union 5 to +∞. There we go. Last example. What is the domain of the function f of x equals the square root of 81 minus x squared? For the square root to be valid, the stuff underneath needs to be 0 or positive. So what's required is that 81 minus x squared is greater than or equal to 0. Well, let's try to write this in standard form. If I put the x squared out front, it looks like -x squared plus 81 is greater than or equal to 0. Well, there's a negative. Let me multiply both sides by -1. X squared minus 81 is less than or equal to 0. Now it's in the form I like. Let's solve this for equality. X squared minus 81 equals 0. Well, that left-hand side factors. X minus 9, x plus 9. And so my two solutions are x equals 9 or x equals -9. I think of the x-axis. I have the 2 points of intersection, -9, +9. This is an upward opening parabola. It goes through those 2 points. And I would like to know, where is that parabola less than or equal to 0? So it's the interior portion. So my x values are the values between -9 and +9. Since it's less than or equal, I can include the two endpoints. So I think I have it. My solution is the interval from -9 to +9, including both endpoints. All right, that is it. We have covered all the basics for solving inequalities involving quadratic functions.